Okay. Continuing our lecture, since the first uh, part was cut, okay. Uh, so we will be calling the deposit method, maybe with an amount of 5,000. Then the balance should be updated. So deposit, or sorry, account one, account one is equals to, or account one dot deposit, okay, will deposit 5,000. Okay, then we'll try to run, save, F1, expected, sorry, save, F5. Okay. So you have your 5,000 deposited, your balance is 5,000. Okay, so that's an example of implementing, okay, or creating a class and creating an object. Okay, so let's discuss the core principles of OOP. Okay, um, encapsulation. Okay, what is encapsulation in object-oriented programming? Encapsulation is one of the core principles of object-oriented programming. Okay, it refers to the bundling both the data, which is the attributes, and the methods into a single unit, which is usually a class. Now, but it's more than just grouping, right? It's more than just a grouping. Encapsulation also uh, involves protecting the data by controlling how it will be accessed or changed. This is more commonly known as data hiding. Okay. Now, instead of letting other parts of the program freely access the data, we will be using a method, okay, the getters and setters, to safely interact with it. Okay, this will help. Okay, number one, to prevent accidental changes. Number two, enforce possible rules like setting only valid values, and keep the code more secure and easier to manage. Now, what are the real life analogies or example of encapsulation? We have mobile phone, right? For a mobile phone, you interact with buttons and screen or the interface, but the internal circuits are hidden to you, okay, or hidden on the users. Next, we have an ATM machine. An ATM machine, you input commands and receive money, okay? The internal logic, however, like the authentication, is hidden to the user or to the account holder. Okay, so now what are the benefits of encapsulation? Okay, encapsulation offers several key advantages when designing and organizing code in object-oriented programming. Number one, it protects internal object state, okay, wherein encapsulation will keep the internal data, okay, like variables, okay, that will be hidden from outside interference. Only the specific methods can access or modify it, which will help prevent misuse or unexpected changes. Number two, it prevents accidental modification. By restricting access to data, it reduces the chances of accidentally changing values that should stay consistent or follow rules. Now you can add checks or validations through your method. Next, it improves security. since it includes data hiding, sensitive information, or logic is hidden inside the class. In this way, other parts of the program can only use the object in safe and predictable ways. What else? It promotes modularity. Encapsulated classes act like a self-contained modules. You can change the internal implementation without affecting the rest of the program as long as the public methods stay the same. Okay, so let's have some example. Okay, so let me just create another one. Okay. Um, in this example, we will try to explain encapsulation using maybe an example of a simple bank account class. Right? In this example, we will hide the internal details of the class, such as the account balance, and then we'll allow access to it only through specific methods. Okay. So first, we define the bank account class, which will have two private attributes. Okay. The owner's name. Actually, it's only a modification of this one. Okay, but we will implement encapsulation. Okay, so class bank account. Okay, then we will now be defining the constructor. Okay, in the constructor init. Okay, I'll be try to initialize two private methods. The owner. Okay, for the account's owner's name and the balance for the initial balance. So def init or initialized, then we have yourself. Then, as we have mentioned, we have two private attributes, which will be the owner and the balance, which we will initialize to 0. Okay. Then, and inside of which we will be initializing or we will be, okay, declaring uh, two private attributes. So self that it becomes a private attribute because it has two underscores. Okay, and, underscore owner is equals to owner. Okay, take note that this will be a private attribute. Then self dot balance is equals to balance. Now, notice the again that or you might notice the of these double underscores. Okay, again, this will make them private, so they cannot be directly accessed outside the class. Okay, so now we will next we will be defining. Okay, I will define the deposit method. In this method, we will try to allow adding money to the account, but it will only accept positive amounts. So let's try to create our deposit method or deposit function. Self amount. Then I'll try to do the operations that if amount, since we will only accept, okay, positive amounts. So positive amounts are numbers that are greater than 0. So greater than 0. Okay, so sorry, self dot balance plus equals dun sa amount. Okay, now within this one, this will control the access, okay, to your balance. Then print, let me just copy this one, okay, paste, then else print natin, print deposit amount must be positive. Okay, now the deposit method, okay, adds the um, amount to the private balance attribute. Okay, this will also ensure that the deposit is positive. Then, if it's not, it will print a warning message. Okay, next, I will be defining a method to get, okay, to get the balance of the account. Okay, wait. Okay, then I'll try to create now or define a method to get the balance of the account. Okay, since our balance is private, this method will um, give us a read-only access. Okay, so I'll try to create balance, get balance. Okay, so what we will be doing is to uh, get the balance of the account. So return self dot balance. Okay, this will be a read-only access to your balance. Now, since this method does not allow changing the balance, okay, it will only return or it will only return the current value of the private attribute. Now, let's create an instance of the bank account, okay, bank account class for a person which we will be uh, which already named kasi we have already here we named it Mark with an initial balance of 0. So let me just copy this one with an initial balance of 0. Then again, we will be depositing 5,000. Okay. Now, finally, um, I will be using the get balance method to check the balance after the deposit. Okay, so print account balance account one dot get balance. Okay, save OOP demo2. Save it as 2. Okay, so the file object has no attribute balance. Uh, ano, bank account. Wait, I'll just resolve it a while. I'll just pause it. Okay. So this is because we are trying to access the self.balance, but the attribute is actually private and it should be with double underscore save. Right, yun. So 5,000 deposited, your balance is 5,000, the account balance is now 5,000. Okay, so that's on how you will be implementing a encapsulation. Okay, oh, so let's proceed to the second core principle of OOP. Okay, so it's the abstraction. Abstraction is one of the fundamental principles of OOP, which involves hiding complex implementation details and exposing only the essential features of an object. The idea here is to focus on what an object does rather than how it does it. Okay? This helps in managing complexity by reducing the amount of information a programmer needs to deal, okay, in any or with a given or in any given time. Okay. Now, what are the key points of abstraction? Okay. It simplifies interaction. Okay, wherein abstraction will allow users to interact with an object or system without needing to understand its internal workings. For example, if or when you drive a car, okay, you don't need to understand how the engine works. You only need to know, okay, you only need to know on how to operate the steering wheel, pedals, and controls. Okay. It also hides complexity. Okay. It hides the intricate details of an implementation. For example, when you call a method like add grade in a class, you don't need to know how the grade is stored internally or how the average is calculated. You just know that calling the get average will give you the result. Okay. Another is that when you focus on high level functionality, the focus is on what actions can be performed on an object, not how they are being carried out. For example, we consider smartphone class. If you interact with methods like call or send message, okay, or even taking a picture, okay, this without need to know the on how the phone works, okay, you do not need to know how the phone works internally to perform those tasks. You don't need to know on how the call really performed, okay, the internal functions of a call. Okay. Now, in a another real life analogy of an abstraction, okay, for if you are using a remote control or a remote, okay, you press buttons, but the internal signal logic is abstracted to you. Okay. Now, why is abstraction important? Okay, it reduces complexity by only showing essential features. Abstraction will help you simplify code and makes it easier to understand. Okay? Then improve. um, increases efficiency, or it improves maintainability. Since the internal details are hidden, okay, changes to the changes to the implementation can be made without affecting the code that uses the class. For instance, if you decide to change how the balance is stored or how deposits are processed, the users of the bank account class do not need to worry, or do not need to worry about it. Okay? It also enhances code readability, or it encourages reusability. Okay? Abstraction helps make objects reusable because they can be defined in a more general way, and specific details of implementation can be handled inside a method. Okay, so let's try to uh, provide an example for an abstraction. Okay, so let me create another file, which we will name it as OOP demo 3. Okay, now we will try to demonstrate abstraction using an abstract class. Okay, abstraction allows us to define a blueprint for other classes, and the implementation details are left to the subclasses. Okay. To begin, okay, we will be using the ABC, okay, or the ABC module, which is part of the Python's standard library. Okay, this will allow us to define abstract classes. So from ABC import ABC, or the abstract base class, abstract method, abstract method. Okay. Now, we define, okay, an abstract class that will be called animal. In this class, this will serve as a template for any specific animal classes, but it won't be instantiated directly. Okay. Uh, Please note, okay, here that we will be inheriting it from the ABC. So class animal ABC. Okay. Then we define the abstract method. Okay. We will be defining an abstract method. Okay, inside your animal class. We'll try to define a method like make sound. So at abstract method, okay, we will define, okay, a make sound method. Okay. Um, this method will not have any body or any operation in its body. It will only serve as a signature that subclasses must implement. So let's just put some keys or terms pass. Okay. Now the abstract method, okay, the abstract method decorator, okay, so, this one, the abstract method decorator will mark that the method, or marks the method as an abstract, okay, which means that any subclass of animal must provide its own implementation of the sound, make sound method, okay, this one. So any subclasses of your animal must provide, okay, an implementation. Now we can in this one we can create an instance of an animal because it has an unimplemented method. So we will now be defining a subclass dog that will inherit from your animal. Okay, so since a dog is a specific animal, okay, it must provide okay, an implementation okay, of the make sound method. So we'll create here class dog and inherit our animal class. Okay. Now, this one we will try to implement the make sound method in our dog. In this dog class, what do you call this? We will be providing the implementation of the make sound. So we will be creating also the make sound. Right? Here, when we called our make sound on our dog or on our dog object, we will print the sounds of a dog, which may be a wolf. Right? Now, uh, since or next is that let's create an instance of our dog class and call the make sound method. So here we will be creating our dog object, okay, or the instance of our dog class. So dog is equals to dog, dog that make sound, right? So save. Yeah. So now abstraction will help define the common interface for a group of related classes. The animal class serves as a blueprint for other animals, and the dog in this case, or the dog class in this case, provides a specific implementation for the make sound method. This will ensure that all animal subclasses will have a make sound method, but each subclass can implement it differently. Okay. So another one is the inheritance. Okay. Inheritance is one of the core principles okay, of OOP, wherein it allows one class, the child or the subclass, to inherit the properties and behaviors or the methods of another class, which is the parent or the superclass. This mechanism will enable the child class to reuse the code of the parent class, and at the same time, it will allow the child class to introduce its own unique behaviors or properties. Now, what are the key points of an inheritance? Inheritance implements our number one, code reusability. Okay, one of the main benefits of inheritance is that it allows code to be reused across different classes instead of duplicating common behavior or child class can simply inherit from a parent class. Number two, it extends functionality. While the child class inherits the properties and methods of the parent, it can also extend or modify those behaviors. This is often referred to as the overriding methods. Then hierarchical relationships. So in terms of hierarchical relationship, inheritance creates a hierarchical relationships between classes. A subclass is a specialized version of the parent class.